So hello Abir, Faiz, how are you?
Fine, sir. How are you?
Also fine. So in the previous class, we were given, you were given some homework, okay, and Jobita has done her homework here. So I have given you the homework to write the chemical formula of calcium phosphate, zinc chlorides, okay. So were you given the valency chart that I have told the
Yes,
faculty
sir.
to? Were you given? Okay. Okay, so let's start with this one. Okay, so now do you know that how to write the chemical formula of the compound? For example, here the calcium phosphate, the formula for calcium phosphate. Let's discuss the homework discussion. Homework discussions. Okay, so let's start with it. So in the previous class, I have given you some homework. So what was that? Let's discuss. Okay. So I told you to write the formula of calcium phosphate, calcium phosphate. Okay, so the formula for calcium is valency of calcium is 2 that you were given. Okay, calcium, and that of phosphate PO4 is actually that is 3. Got it? So when you cross multiply these two, you will get CA3 PO4 whole twice. Okay, so this is the correct formula that Jubita has done correctly. Okay, how many students have sent me the homework?
Sir, I have also sent. I
Yeah,
have also
Jovita, I
sent,
have.
sir.
Who is I have? Let me check.
Tejasvi. Tejasvi has sent the
Tejas,
homework. And
Tejasvi, you
Abir
have sent.
also.
And Abir, you have also sent the homework. Okay. Yeah. Very good. Proud of you. But is there? Yes. I'm watching here that the assignment for Abir is also has also given his homework, and Tejasvi is Riya's assignment for us. Okay. So I have seen. I'm checking here. Okay, let me check. Let me check if anyone is having any problem regarding to this one. So please let me know if you are having any problem. So regarding to that you homework, if you are having any problem, please let me know. Or should I discuss one by one question, all the questions? Okay, let me check it. I'm going to get that to you. Wait a minute. So I have given you the formula. Dear students, it's mentioned that you need to do your formula. Sorry, you need to do your homework properly on time. And moreover, please check it now. Okay, if you are having any problem, then please check it. Okay, the formula for the zinc chloride is Zn. Zn is having valency 2, and that of chloride is 1. Chloride ion is 1 Cl. That is Cl. Okay, that is Cl. So the formula for zinc chloride will be ZnCl. Got it? Now moving to the next part is iron sulfate or ferrous sulfate. Iron is going to have two types of valency, that is +2 and +3. When iron is going to have ferrous, when it is said ferrous, so it is going to have +2 valency. And when it is said ferric, then it is going to have +3 valency. For example, if it is being asked, write the formula of ferrous oxide. The formula for ferrous oxide is F is going to have +2 valency, and O is also going to have +2 valency. Sorry, -2. So both of them will be cancelled out, and this will be FeO. FeO is actually ferrous oxide. Ferrous oxide. Got it? And if somebody asks you to write the formula of ferric oxide, so ferric oxide is iron is going to have +3 valency, and oxygen is going to have 2. When you cross multiply these two, you will get Fe2O3. Got my point?
Yes, sir.
Got it? Okay. Now moving to the next type is that ferrous sulfate. Then the next one is if it is being asked ferrous sulfate. The formula for ferrous means 2, and sulfate is SO4 ion. That is also 2. When you cut these two, you will get FeSO4. Okay. Now moving to this next one is lead nitrate, PbNO3. Pb is actually having valency 2, and NO3 is going to have valency 1. When you cross multiply these two, this is PbNO3 whole twice. Why whole twice? Because this is treated as single entity. Okay. So when you are going to write it, that you can write it properly, that PbN3. Got my point? Is everyone is understanding or not?
Yes, sir.
Understanding, sir.
Next one is that this Abir has not done this one. That is zinc acetate.
Acetate, yes.
Yes, zinc acetate. So zinc is Zn. Okay, and acetate ion is CH3COO minus. This is acetate ion. This is acetate ion. Keep in mind that this is zinc and this is acetate ion. Acetate. Okay, you will be familiar, but every student will be familiar. Every student will be familiar for these type of ions, because this is your first chapter till the end of 2 or 3 chapter when you have studied. So you will be familiar with acetate ion, with carbonate ion, with bicarbonate ion, with sulfate ion. Because you are studying this ions for the first time, and this is you have studied also in 9th standard, but let it be. Okay, we are just going to start from beginning. Chemistry we have studied from beginning, so let it be. Okay, so this is acetate ion CH3COO minus. Okay, now zinc is going to have positive 2 valency and acetate ion is -1 here. This is 1. When you cross multiply these two, you will write here Zn CH3COO minus. Okay, a whole twice. But it is familiar that this is not written like this way, but in general it is written like this way. CH3COO whole twice, and this Zn is written here. Because actually in this molecule CH3COO minus, the minus charge is on CH3C will bond O minus. This is going to have the minus charge. This oxygen, second oxygen, is going to have minus charge. So the positive entity will going to join with this one. Got my point? Got my point? So this
Yes,
single
sir.
entity, this single minus ion is having minus charge. This oxygen ion is having minus charge. So this zinc will attach with this one. If you write this like this way, it means that it is attached with carbon. No, it is not attached with carbon. So the correct way to write this formula for zinc acetate is this one. Zinc acetate. Zinc acetate. Got it? Got my point?
Yes, sir.
So Abir, please wrote it down. Okay.
Noted,
We are
sir.
not- okay. Moving to the next part is sodium zincate. Sodium zincate. Now, what is the formula of sodium zincate? Anyone of you have written this one? Let me check.
Na2Zn
Very good. Na2.
ZnO2.
Yes, Na2ZnO2. So sodium is having +1 valency and Zn is going to have ZnO2 is zincate ion that you have also seen in your chart, that ZnO2 is having -2 charge, -2. So when you cross multiply this one, this is zincate ion. This is ZnO2 is zincate ion. ZnO2 is called zincate ion, zincate ions. Okay. So when you multiply this one, Na2, ZnO2. Okay. So this is the formula for the sodium zincate. Got it?
Yes,
Got
Yes,
sir.
it?
sir.
Okay. Now moving forward, let's check the other points of this homework. That is, what happens when sodium react with metals? Okay. So sodium when react with metals, what would happen? So sodium react with sodium. You have to complete this section. Sodium when react with H2SO4, sulfuric acid. Sulfuric acid is actually H2SO4. Sodium is Na and sulfuric acid is H2SO4. Okay. So actually this is a type of displacement reaction in which more reactive element displaces the less reactive element. So what would happen? This sodium will remove this hydrogen from this one and will form sodium sulfate. Sodium sulfate. The correct formula for sodium sulfate would be?
Na2SO4.
Yes, Na2SO4. The valency of sodium is actually
1.
and that of sulfate ion is 2.
2.
So beta, you need to memorize this one properly, each and every student. Okay. Na2SO4. Got my point? Plus
Yes,
hydrogen
sir.
gas. So this is a general equation that you will learn, that when metals react with acid, they form salt plus hydrogen gas. Okay. And this is the salt. Na2SO4 is a type of salt. Okay. Now moving to the next one is magnesium react with ethanoic acid. Tell me what would form? Magnesium react with ethanoic acid. What is ethanoic acid? What's the formula for ethanoic acid?
CH3COOH.
CH3COOH. This is the formula for ethanoic acid. Ethanoic acid. Okay. So what would form? Name the product. Form. What would the product? So you know that when this will be liberated, CH3CO minus and H positive ion will be displaced by this one. Okay. Got it. What would happen here? Tell me. What would happen here?
MgCH3COO.
This is CH3COO minus that is going to have one valency, and magnesium is going to, since I'm writing magnesium here on this side, in general we write the plus ions on the left hand side and this negative ion on the right hand side. But in case of acetate ion or this ion CH3CO minus, we have to write this one on the right hand side. Why? Because this is the negative charge and this is the positive charge. This Mg is going to attach with this O. Okay. So then again, magnesium valency is 2. When you multiply this 2, you will get CH3COO, and this 2 will going to have in the bracket, and then okay. Got it?
Yes, sir.
Got it?
Yes,
Pies,
sir.
you
go ahead.
understood? Pies, you
Yes, sir.
understood? Tejasvi?
Yes, sir. Understood, sir.
Okay, Jobita, you understood?
Yes, sir.
So what would happen? Actually, this is metals. Metals when react with acid, they form what? Salt, and the salt name will be CH3COO whole twice Mg plus hydrogen gas. Got it?
Yes, sir.
Got it?
So what is the name of the salt?
This salt, the name for this salt is magnesium acetate.
Yes,
The
sir.
previous one, what was the name? What was the name of this salt?
Zinc
was the-
acetate.
Zinc acetate. This is zinc acetate. Okay. So the name for this salt will be
Magnesium
magnesium
acetate.
acetate.
Yes,
Okay?
sir.
Magnesium acetate, or you can write magnesium ethanoate. Like it is having the name for this one is a common name. Okay, let me explain you this one. This is CH3COH. It has two names. One is the ethanoic acid, and another one is the acetic acid. Acetic acid. Okay, so if you are choosing this acetic acid, so you can write magnesium acetate. Magnesium acetate. But if you are choosing this ethanoic acid as its name, so you can name it magnesium ethanoate. Ethanoate means this ion CH3COO minus, it has two names. One is the acetate ion, another one is ethanoate ion. What's my point? Ethanoate ion. So copy this one. This has two names.
Yes, sir. Noted.
Okay, now moving to the next part is zinc. Zinc when react with HCl, what would happen?
ZnCl2.
Yes, it will be ZnCl2 plus hydrogen
Plus
gas.
H2.
Why hydrogen gas?
Zinc displaces hydrogen from hydrochloric acid.
Okay, because it is more reactive than hydrogen.
Hydrogen.
The reactivity is okay. And why I'm writing here ZnCl2? Let me wait. Let me ask. Okay. Yes, Shweb, tell me, beta. Why I'm writing here ZnCl2? Why I'm not writing ZnCl? Shweb, are you there in the class?
Yes, sir.
Can you tell me, beta, why I'm writing here ZnCl2, not ZnCl? Because it is replacing this hydrogen, so it will combine it together from ZnCl2. Is it your first class, Shweb?
No, sir.
Can you please introduce yourself?
Muhammad Shaikh.
Your voice is not coming. Where you studied from?
Yeah, I'm studying from India right now.
Studying from India, Hyderabad,
No, Chennai.
Chennai. Okay. Okay. So here's the problem that why we are not writing ZNCl why we are writing ZNCl2 instead of why we are not writing ZNCl, because the formula for zinc chloride is not ZNCl. It is actually ZNCl2, because zinc is going to have 2 valency and that of chloride ion is going to have 1
One.
valency. And when you multiply it with this 2, you will get ZNCl. The proper formula should be written. We cannot write H2O. If sometime we cannot write HO. This is water. This is not water. This is not water. Not water. Okay. So in a chemical compounds, elements are combined together in a fixed ratio by mass or in a fixed ratio. If is zinc atom, with zinc atom, 2 chlorine atoms can join. So the formula will be ZnCl, not ZnCl. Okay. It does not mean that if we are having some other element, so it does not means, got my point? If, for example, zinc is reacting with H2SO4, so in that case, it is forming ZnSO4 plus hydrogen gas. Okay, we are just displacing. Why ZnSO4? Why not Zn2SO4? Why?
Because both have valency of 2.
Because both are going to have valency of 2. Here you see that is zinc is going to have valency 2, and SO4 ion is also going to have valency 2. The bits will cancel out, and the formula for zinc sulfate will. So we have to write the correct formula. We have to write correct formula of salt. Okay, correct formula of salt. Correct formula of salt. Okay, got it. So later the other part of the homework we will discuss later. So let's move further. So what we were studying in the previous class? Last topic, can you explain me? Can you tell me which topic you were studying? You were studying which topic? I think metals and non-metals, chemical properties of metals and non-metals we were discussing.
Yes, sir. We were talking
So,
about metals with water.
metals reaction
And
with
the
water.
last part we studied is magnesium reacts with only hot water to form magnesium hydroxide.
Okay, I understood. So here it is. Let's start. So magnesium react with hot water. Now the question here comes. I have given you the question in the homework, but I have not written it. Actually, there is a condition for reaction with metals with water. So what are the conditions for reactions? I have also discussed this in the previous class. Let me explain you this one more time. That metals, when react with water, they form metal oxide. They form metal oxide plus hydrogen gas. They form metal hydroxide slash metal oxide plus hydrogen gas. And this metal, if the metals are potassium, sodium, calcium, and magnesium. So these 4 elements are going to form metal hydroxide. And this element is going to form other element, aluminium, zinc, iron. They are going to form what? They are form metal oxide and they react with it. Got it? The element that come below the hydrogen did not react with water. Why? Because they are not able to displace hydrogen from water, because it is a displacement reaction. Got it? Now moving to this part is that we have discussed there are some conditions that calcium and sodium react with chilled water. Can react with chilled water means ice. In fact, ice. Calcium react with cold water. Okay. Cold water. Okay, and that magnesium react with hot water. And these 3 elements react with steam. And this is iron should be red hot. Iron should be red hot also. Got it? So this we have discussed. Now talking about the point, now we have discussed these all in the previous class. So let's move further. The question for today is why does calcium float on the surface of water? Why does calcium float on the surface of water? So actually, when calcium is added to water, dear students, when calcium is added to water, so what happens? Let's suppose this is a calcium metal. Okay, this is the calcium metal. So when it is added to calcium metal is added, so what would happen? It is start floating over the surface. Why? Because it is producing hydrogen gas and it react at very faster rate. Okay? So what would happen? It is start reacting with this water, and this is the hydrogen gas bubble. Hydrogen gas bubble. Gas bubble. And you know that hydrogen gas is this, and these bubbles start producing at very faster rate and will produce an upthrust. Upthrust means, what do you mean by upthrust? Upthrust means that
Upward push.
yeah, upward force. Okay, that is produced like in the rocket you have seen. Okay, and moreover the buoyant force. If you are having a bag, or if you are having a tube, okay, and then if you means the tube filled with air, what would happen? What it apply? It will help you to swim. So similarly, these bubbles is got to stick with the surface of this calcium metals, and this help it to float. Okay, so this is an important question. Please note it down. That why do calcium float on the surface of metals? So please note it down. It is. Please note it down. Calcium float on the surface of water because when calcium comes in the contact with water molecule, it produces hydrogen gas. Why? Why it is producing hydrogen gas? Because calcium is a metal, and when it react with water, it form calcium oxide plus hydrogen gas. So this gas bubble sticks. Are you getting, Jobita? Are you listening?
Yes, sir.
Okay. So I'm saying that this gas bubble stick with the surface of calcium. This gas bubble stick with the, and provide its upthrust, and make it float. Moreover, calcium is very reactive. The other metals also produce hydrogen gas. For example, if I'm talking about the magnesium, so magnesium does not magnesium is lighter in weight. The mass of magnesium is 24, and that of calcium is 40. But calcium is less, magnesium is less reactive. In the reactivity series, you see potassium, then after sodium, then calcium, then magnesium. So you see this is calcium. Here the calcium is more reactive. Okay, beta, okay. Let's wait. Okay, so this is sodium, and after this one is calcium. So magnesium being lighter weight, it does not float. It tried to float, but again come down, then try to float, then but calcium readily float on the surface. I mean, it directly float. So why it is floating? Why? Because calcium is more reactive. It can, when it react with water, it can produce sufficient amount of hydrogen gas spontaneously. Okay, produce sufficient amount of hydrogen gas with provided upthrust. Okay, got it. So why do other metals do not? Because iron do not float. Why iron do not float? Because iron is less reactive. It produces the hydrogen gas, but it not produce so at the rate at which hydrogen gas is produced in iron or in magnesium. It is not so much that it can let the magnesium or iron float. But in case of calcium, because calcium is very reactive, and moreover, the reaction is not so exothermic that the hydrogen gas do not catch fire. But in case of sodium and potassium, you see that these two get catches. Means when the hydrogen gas produced, the reaction is so exothermic that it led the hydrogen gas to catch fire. Means in case of potassium, when you add it to water, so when you add it to water, it will form KOH plus hydrogen gas. Okay, so this hydrogen gas burns. Why? Why it burns? Why it burns? So it is simple, because the heat is produced in so much amount that it led the hydrogen gas to catch fire. But in calcium, in case of calcium, it do not react. It reacts CaOH. It will form calcium hydroxide plus hydrogen gas. But this hydrogen gas do not burn. And the production is so large, is sufficient enough that it made the calcium to float on the surface of the water. Got my point? Got my point?
Yes, sir.
Please note it down fast. At a faster rate, please note it down.
Noted, sir.
Other?
Just a minute.
Guys, have you written?
No, sir, 1 minute.
Please note it down at faster rate. My dear student, don't take the screenshot, because after you take the screenshot, 90% of the students are not going to write the answer in their copy. So please, if you are taking the screenshot, I'm not saying that don't take the screenshot. You may take, but it is mandatory for you that you must prepare the notes. There will be a date when I will give you that, and I will ask you to send the screenshot for the whole chapter that you have completed. So at that case, at the time, you have to send me the photographs of all the chapter, whether you have prepared the proper notes of everything. Okay.
Yes, sir.
I
Done,
don't
sir.
think that your
Yes, sir, done.
other students. Okay, let's move forward. Now moving to the two properties we have studied. One is metals when react with acids, and metals when react with what? Metals when react with what? Okay, H2. Now the third and very important property is metals when react with base. What would happen when metals when react with base? Okay, let's start. Let's start. What would happen when metals react with base? Metals when react with base. Metals when react with base, they also form salt plus hydrogen gas. But there is terms and condition. What is that terms and condition? That the metal should be either zinc, aluminium, and lead. And the base should be NaOH or KOH. Most probably this is used, that is it should be warm. Okay, got it? Got it?
Yes, sir.
Now moving to this one is when metals react with base. Let's suppose if I'm having zinc react with NaOH, so it will form sodium zincate plus hydrogen gas. So what's the formula of sodium zincate? Tell me. What's the formula for sodium zincate?
Na2ZnO2.
Yes, we have discussed this one. So here the compound form will be Na2ZnO2. Got it? Now moving next to the next part is when metals, like for example, if aluminium react with NaOH, it forms sodium aluminate. The formula for this one is NaAlO2. Here there is no 2. So please remember that here we are having 2, but here we are not having 2. Because the valency of AlO2 is actually -1. So when it reacts with sodium, it forms 1, 1. The formula for this one is NaAlO2 plus hydrogen gas. The next one is zinc, aluminium. Next one is, that is Pb, lead. Lead when react with NaOH base, it form sodium plumbate, Na2PbO2 plus hydrogen gas. This is very important. So please note the name of each and everyone. This is sodium zincate. And what is this? What is the name for this one? Tell me. What is the name for this compound? NaAlO2. NaAlO2, what is the name for this compound? Tell me. Tejasvi, are you there?
Yes, sir.
What's the name for this one? NaAlO2. It is sodium aluminate. Okay, and this one is sodium plumbate. These equations are also in NCERT, so it is must that you need to remember these problems. This is very, very important for examination point of view. For examination Okay, so this is very, very important. Metals property with base. Okay. And these
Yes,
three
sir.
are going to be. Okay, so please note it down properly and write their names also.
Noted, sir.
Other students? Abir?
Just a minute, sir.
Yes, sir. Noted.
Okay. Jobita, you done?
Yes, sir.
Jobita,
Yes, sir.
is there anyone who's left?
Done, sir.
So please note it down. Note it down. Okay, this is very important. So let's move further. And these are metals. So we are having these things common that metals when react with acid, they form salt and hydrogen gas. Metals when react with acid, they form salt plus hydrogen gas. Metals when react with base, they also form salt plus hydrogen gas. But there are conditions here for metals and here also that not every metal is going to react with acids. Which metals are not going to react with acids? Tell me.
The metals below hydrogen in the reactivity series will not react.
Very good, very good. Very good. Next property of metals. Metals when react with oxygen, they form metal oxides. And generally, metal oxides are basic in nature. Okay, generally, metal oxides. Why metal oxides are basic in nature? You know that NaOH is base. Okay, and how this NaOH is formed, that I have discussed in the previous class. That if I'm saying that Na when react with water, it will form Na2O. Okay, and since this Na2 plus hydrogen gas. Okay, and actually this Na2O further react with water and form NaOH plus NaOH. Only this one NaOH. Okay, so this intermediate we don't get. We don't get. We get overall reaction. That is Na when react with water, it form NaOH plus hydrogen gas. So here you know this is metal oxide. This is metal oxide. And when it dissolve in water, Na2, when dissolve in water, it form base. So NaOH is base. So keep in mind that Na2O, yeah, ZNO, yeah, MgO, these are all basic in nature because they form MgOH whole twice. They form calcium hydroxide, okay, when react with water. Got it? Got it?
Yes, sir.
Got it? That calcium oxide when react with water, it form calcium hydroxide. So this is metal oxide. So metal oxides these are basic in nature. These are basic in nature. Got it? Got it? Is there any doubt regarding to this point?
No, sir.
So please.
No, sir.
Okay. So generally they are basic in nature, but there are some oxides that shows both acidic as well as basic behavior. There are some oxides that shows both acidic as well as basic behavior. There are some metal oxides, and these metal oxides are called amphoteric in these metal oxides are called are amphoteric in nature. So keep in mind how I'm going to explain you this one, amphoteric nature of amphoteric metal oxides. So what is the definition for a metal oxides? Those metal oxides that show both acidic
And basic nature.
acidic and basic nature. How can I say this one? Basic nature. So let me compare it. Okay, you know that acid when react with base, what they form? Tell me. When acid react with base, what they form?
Salt and water.
Salt and water. Okay. Jobita, is this correct? When acid react with base, they form salt and water. This is correct? Jobita, are you there? Shoaib,
Yes, sir.
is it correct?
Yes.
Yes. So it is simple. When acid react with base, they form salt plus water. Okay. So if I'm writing here salt plus water. So if I'm writing H2SO4, sulfuric acid, H2SO4 when react with ZNO, If it react with only zinc, what would happen? If it react only with zinc, what would happen? Tell me what's the product here form?
Zinc sulfate, ZnSO4 plus H2.
Plus H2 hydrogen gas, because this is acid, this is metals.
Metal.
Metals when react with acid, they form salt plus hydrogen gas. But if I put here O, then it will form water. Okay. Got it?
Yes, sir.
Got it?
Yes,
Now
sir.
you can consider this is salt, this is water, and this is acid. So it would be here base. Comparing this equation, this should be base. So ZNO here is acting as a base. Okay. Got it? Now moving to the next question is ZNO. When react with NaOH, it form. If Zn react with NaOH, what would happen? Only NaOH. Tell me. What will form when Zn react with NaOH? Tell me.
Na2ZNO plus H2.
What name of the compound?
Zinc oxide.
Check
Sodium.
Check it out. Previously, we have done a little bit
Sodium
2 or 3
zinc.
pages. Yes, it will form sodium zinc. We have written this one on the previous page.
Yes.
Okay. This is metals. When react with base, it will gives you salt. Na2ZnO. Got it?
Yes, sir.
Got it?
Yes, sir.
So if I put this one O here, so this will be also O. Water. So here you took that this is a base, NaOH base, and this is salt. Na2ZnO2 is salt, and this is water. So this should be acid. Acid. Got the point? It should be acid. So here the ZnO is acting as a base. Here the ZnO is acting as an acid. So when ZnO react with NaOH, means with base, it shows acidic behavior. So acidic behavior here. Okay. Acidic behavior. And when this react with ZnO react with acid, so it shows basic behavior. Basic behavior. So got my point. So ZnO is showing in some case ZnO show acidic behavior. Some case it show basic behavior. So those metal oxide that shows both acidic as well as basic behavior are called amphoteric oxides. Okay, got it?
Yes, sir.
So please note it down. Note this whole page. When you're done, please let me know. Okay.
Noted, sir.
So this also those metal oxide that shows both acidic as well as basic behavior is called amphoteric oxide. Just amphoteric, the correct spelling for amphoteric.
Noted, sir.
Other students done? Abir, Shweb, Shweb, Faiz, Jobita,
Done, sir.
not done. Sure.
Yes, sir.
Please read my request that you need to maintain the proper note. If you are not writing properly, so please maintain your notes, okay? So moving to the next part is metals when react with hydride. Okay, hydride means the hydrogen gas. They form metal hydride. They form metal hydride. For example, lithium when react with hydrogen, it form LiH. You need to keep in mind here that generally the hydrogen is going to have +1 valency. But in case of hydride, it is going to have -1 valency. So when it is going to have -1 valency, we call it hydride, like bromide, like chloride. Okay, chloride, bromide, okay, chloride, fluoride, oxide, okay, sulfide, nitride. So IDE, it admits IDE, okay, hydride. But in case if it is having +1 valency, we'll write hydrogen. We'll write hydrogen. For example, hydrogen sulfide. Formula for hydrogen sulfide is hydrogen is going to have +1 valency, and that of sulfide is going to have -2 valency. This is +1, this is -2. This is will cross multiplied from H2S. This is hydrogen sulfide. But the formula for hydride, when it form hydride, in case if it is metal, if it is reacting with metal, because metals are super positive charge, they cannot accept the electron. They always donate the electron. So in that case, what would happen here? Sodium is, if I'm having the formula for sodium hydride, then it will be sodium valency 1 and hydrogen is going to have -1 valency in that case, because hydrogen can also accept the electron. It is going to have 1 electron. So in order to complete duplet, because the first shell is going to have 2 electron, maximum 2 electron. So it can accept the electron in order to do the duplet. So it can have the formula NaH. So if it is calcium hydride, calcium is going to have 2 valency and hydride is going to have -1 valency. It will multiply, cross multiply, it will be CaH2. Okay, got my point? Magnesium hydride, calcium hydride. But below magnesium and calcium, the other hydride is not formed, because other metal do not form hydride, because the size of hydrogen is very, very small. And the size of metal is as comparison to metal. So if we have a metal like this in size and hydrogen is like this size, the bond does not form very stable. So if I'm saying why do other metals do not form hydride? All the metal do not form hydride because hydrogen is a very small in size, and the bonds with other elements, other metals do not make, because sodium is not bigger, very much bigger in size. So it can make bond with this one. Okay, but in case of other element that is very bigger in size, so in that case, these are generally the element that form hydride. Okay, so that is lithium hydride, sodium hydride, calcium hydride, CH2, KH. Here, hydrogen is showing the property as that of similar to the non-metal. So hydrogen sometimes show the property of metal, sometimes it show the property of non-metal. How can you say this one? How can you say? For example, like hydrogen form H positive ion, sodium also form H positive ion, potassium also show H positive ion. So when it form positive ion, it's showing the property similar to metals. Okay, similar to metals. But when it form hydride, so like Cl minus is formed. Okay, fluoride F minus is formed, Br minus is formed. So here it is showing minus. So it is showing the property of non-metals. Okay, non-metals. It can form hydrogen, form H2 gas, hydrogen form H2 gas, hydrogen form like other elements like Cl2 is formed, Br2 is formed. Okay, O2 is formed. The hydrogen also form a molecular gas molecule. So this is also the property of non-metals. But like the sodium form NaCl, okay, potassium form KCl, hydrogen also form HCl. So it is showing the property of metal. Sometimes it shows the property of metal, sometimes it shows the property of non-metal. So we don't have categorized, we don't have a specific category that whether the hydrogen is metal or a non-metal. Got my point? Got my point?
Yes, sir.
Yes, sir.
Is that clear? Is that clear to everyone? So let's move.
Yes, sir.
Please note it down. Please note it down. Everybody, please note it down. Metals when react with hydrogen, it form metal hydride.
Noted, sir.
Other students? Other students? Jobita, Shoaib,
Done, sir.
are you getting what I'm teaching you, or is it going above your mind, above your brain? Are you getting?
Yes,
Yes,
sir.
yes.
So please, every other students have noted. Shoaib, have you noted this one? Tejasvi, are you there?
Sir,
Some.
I have noted, sir.
Okay. So let's move further. Let's move further. Okay. That is a bond. Now, bond formation between metals and non-metals. Bond formation. Formation between metals and non-metals. Okay. So if I'm talking about that, what bond is formed? There are two types of bond that we study. One is the ionic bond. Ionic bond or electrovalent bond. And other one is the covalent bond. This bond is formed between negative and positive ions. This is bond formed between by sharing of electron, by sharing of electrons. Here they are not sharing. What are they? One element is completely losing. One element is completely losing. Is completely losing. And other is permanently gaining. Got it? Got it? Understood?
Yes, sir.
Sure? Understood, everybody?
Sir, losing electrons, right?
Yes, losing
Yeah.
electrons. So note it down. Bond formation.
Noted, sir.
Other,
Just a minute.
okay. So let's move. You know that metals react with acids. Actually, what we were discussing the formation of ionic bond. Okay, formation of ionic. For example, if I'm having sodium. Okay, so the question will be asked: write down the structure, how the formation of sodium chloride bond is formed. Okay, so actually sodium is going to have electronic configuration 281. Atomic number of sodium is 11. This is atomic number. How many students in the class don't know about the electronic configuration? Jupiter, you know. Faiz, you know about the electronic configuration?
Yes, sir.
Shoaib, you know? You know
Yes,
about
sir.
the electronic configuration? Okay. So this is for sodium. That is, first shell is going to have maximum 2 electrons. Second shell can have maximum 8, and third shell can have also maximum 8 for your syllabus. In your syllabus, it can have 18 also, but the 20 elements are in your syllabus. So for you, I can say that the third shell can occupy at maximum 8 electrons. Okay, so now moving to the next one is, that is chlorine. It is atomic number is 17. So what should be the electronic configuration? Tell me for chlorine.
287.
287. First shell, second shell is 8, and this is 7. 2, 8, 10, and then 17. Okay. Now, you know that the nearest noble gas for sodium is neon, and that is going to have 288 electronic configuration. And for this chlorine, the nearest noble gas is argon, that is going to have 288 electronic configuration. And now it is mandatory that you need to understand here one thing, that every element in the nature wants to be stable and wants to have the near electronic configuration to the nearest noble gas. For example, the nearest noble gas for neon is actually 2,8, and that of argon is 288. So chlorine wants the electronic configuration to become like 288, and this neon wants, sodium wants to become 2,8. It wants to lose this electron, and it wants to gain 1 electron. So what would happen here? Sodium will lose 1 electron and form 2,8 and will acquire a positive 1 charge. And that similarly, the chlorine is going to gain this electron. Sodium is permanently losing and giving 1 electron to chloride to chlorine, and it will form 288. So here, both of them are going to hello. Hello, Shreyash. Are you there in the class? Shreyash, are you there, beta? Shreyash,
Yes,
I'm
sir.
asking you. Are you there?
Yes, sir.
You have missed the whole class because the class started at 7:30. Okay, sorry, 6:30. So what you need to do here is that the same topic I am going to teach in the next batch, and that will be going to start from 9:30 according to the Indian timing. Okay, 9:30. So what's the time right now? From where you are studying?
Sir, India 7:26.
So that's at 7:26 now. So okay, so join it at 9:30 sharp. Okay.
Sure,
You
sir.
can leave the class because the topic has missed and you will not get anything from
Sure,
this.
sir.
Yeah. So join at 9:30. Okay. So coming to the point, that one is Na positive and Cl minus. Okay. So this is 2,8 and this is 288. Okay. So what would happen here is that this is sodium is going to have +1 and this chlorine is going to have minus 280 electron. Now both are stable. Sodium has loses 1 electron, chlorine has. Now again, why they are forming? Why they are coming closer to each other? Because of the strong. Because when sodium loses 1 electron, it acquires +1 positive charge, and when chlorine get 1 extra electron, then it get 1 negative charge, and this is called the electrostatic force of attraction, and that is 10 raised to the power 48 times, approximately 48 times more than the gravitational force. So this is very, very large number. Okay, so we can say that electrostatic force is very, very high. So the atoms will tightly hold together. The sodium positive and chloride ion will tightly hold together, and they will form a ion, and that is called sodium chloride ion. Sodium chloride molecule. Got it? So what would happen? How can you structure? How can you define? So you know that the electrons that are present in the outermost shell participate in the body. Write a point here that the electrons of outermost shell participate in the bonding. Got my point? That the electrons of the outermost shell participate in the bonding. Okay, the innermost electron do not, inner electron do not participate. So if I'm having this sodium, that is sodium, and it is having one electron here first, and that is chlorine, that is going to have 7 electron in the outermost shell. So okay, so write the electron configuration 281 here, 287. This is the step 1. In this step, you need to show the electron that it is transferring to the chlorine. Okay, now show the next, in the next step, when it has given the electron, show this one, this is positive, and the electron configuration is 2,8. And show this received electron, that chlorine has received 1 electron with 1 negative charge, so that it. This is the second step. Third step is just write Na, just with 1 positive charge, and this is Cl with 8 of its electron, outermost shell electrons, and with 1 negative charge, and this is NaCl. Got my point? Got it?
Yes, sir. Yes, sir.
So please note it down. This is, you have to represent. Don't miss any one of this. You have to make. You have to show the electron dot structure, and this is called electron dot structure, or it is also called Lewis dot structure. We also call it Lewis dot structure. Got my point? Got it?
Yes, sir.
So please note it down fast. Done?
Yes, sir. Noted. Done.
Okay. So today I'm going to give you some homework, dear students, and you have to read that why do this type of compound formed is called ionic compound, because it is positive and negative, because these are the ions. Ions, what are ions? Ions are positively or negatively charged
Atoms.
atoms. Okay, you can see positively charged is called cation, and negatively charged is called
Anion.
Okay, now moving to this one, I'm going to give you some questions, and that will be good to write answer that why do the ionic compounds are solid in nature? Why they are generally solid? Because they are tightly held together with a strong electrostatic force of attraction. Okay, you need to explain it that they are tightly held together with a strong electrostatic force of attraction, as a result of which a large amount of energy is being required to separate these ions. Okay, so because they are solid, what solid needs to have their particles continuously moving to come into the liquid state. Okay, so their strongest electrostatic force of attraction is there, so they are not. Similarly, why they are not able to conduct electricity? This is the same answer, that because their ions are not free to move. What do you read? Ions are not free to move. So if the ions are not free to move, ions are responsible for carrying electricity, for conduction of. If they are not free, they are tightly bonded together. Na is attracted with Cl minus. So in this case, you will write there, because they are hold together. The positively charged and negatively charged are hold together. The ions are tightly bonded together, so they are not free to move. So they are not able to conduct electricity. Okay. So what would happen here? Okay, I'm going to end the class. Okay. So what would happen here, dear students? So in this case, sodium and they